Hello, this is part two of graphing standard form quadratic functions. So let's just finish up. So we have y equals negative x squared plus 2x plus 5, and we got to graph it completely. So let's find the vertex first. So let's figure out our a and b and c. So my a is -1, my b is 2, and my c is 5, correct? And let's find the x value. So x is opposite of b over 2a. So the opposite of b is -2 over 2 times a, which is -1. So that's -2 over -2, which is 1. Then you plug in 1 into the function, right? So it's negative parentheses 1 square plus 2 times 1 plus 5. So 1 square is 1, and then you have a minus, so that's minus plus 2 plus 5, and that gives you 6. So it looks like our vertex is at 1,6. Let me confirm it with Desmo. Yes, the vertex is at 1,6. So my axis of symmetry is x equals 1. And then let's find the y-intercept. You plug in 0 into the function, which is 5. 0, 5. Okay, let's figure out if we have x-intercepts. So b squared minus 4ac. B squared is 2 minus 4 times a, which is 1, -1. And c is 5. -4 times -1 is +4. Times it by 5, that's 20, right? -4 times -1 is +4 times 5, which is 24. So that's greater than 0. That means we have 2. Yeah, let's find it. So if we let's find our x-intercept y to 0. Can we factor this nicely? It might work if we divide everything by negative. No, it wouldn't. Darn. I thought we could if we divide everything by -1. It still wouldn't work. Negative. That would make the 5 negative, and then that would make the 2 negative. So yeah, it wouldn't work. So quadratic formula. So x is opposite of b, which is -2, plus or minus root. B squared is 4 minus 4 times a, which is -1. C is 5 all over 2 times -1. That's 4. And then -4 times -1 is +4 times 5. That's 20, right? -4 times -1 is +4 times it by 5. That's 20 all over -2. So that's -2 plus or minus 24 all over -2. So my two x-intercepts, well, one of them is at -2 plus square root of 24 all over -2, which is -1.4. And then our other one is -2 minus square root of 24 all over -2. That's 3.4. So my two x-intercepts is negative 1.4 comma 0, and then the other one is 3.4 comma 0. Okay, and what's my vertex? It's 1 comma 6, so it's 1, 1, 2, 3, 4, 5, 6, 7, 8. 1 comma 6 is 2, 4, 6. Okay, my y-intercept is 0 comma 5. And by the way, there's a minus here, so it's concave down, right? And my two x-intercepts are negative 1.4. Here's negative 1. Negative 1.4 would be right about here. And then 3.4 is 1, 2, 3. Right about there, right? So it should look something like this. Okay, and then your axis symmetry is this vertical asymptote, which is x equals, what is it? What's our x value of the vertex is 1. Okay, so that was our graph. Now let's find the domain and range. So domain is still all real numbers. Doesn't matter if it's concave up or concave down, it's all real numbers. The range is not all real numbers, so be careful, it's concave down. So we go from smallest y values to largest y values. So what is my smallest y value? It looks like it shoots down to negative infinity. So it's going to be from negative infinity. And what is our highest y value? It's related to the y value of the vertex, which in our case is 6. So it stops at the y value 6. And then we do include it, so bracket. Okay, go ahead and pause. And let's move on to the next one. Example 4 says, find the quadratic function in standard form that has given the indicated vertex and whose graph passes through the given point. Okay, so this one we don't have to graph. What we want is an equation in standard form. So our final answer will have to be in y equals ax squared plus bx plus c. Okay, so they tell us two things, the vertex and a random point on that graph. So what I would do is put it in vertex form. So I think it would be a lot easier. If I put it in vertex form, then I can convert it to standard form because you would just have to FOIL and clean it up, right? So vertex form is y equals a parentheses x minus h squared plus k, correct? Now we actually have the k and the h value. The h is the 4, the k is the negative 1. So we don't know our a is. So it's going to be y equals, and if you remember, the x value of the vertex is the horizontal shift, and horizontal shift is always the opposite sign. So even though if your x value is 4, in factor form, it's actually the opposite. It's x minus 4, right? Because what this means is you're shifting it 4 units to the right, which is why it's positive 4. And then our k value is the y value of the vertex. You do not have to change the sign. It is what it is. Okay, so we're almost there. Now we got to do is find out our a value. So how do you find your a value? So you use this point, your given point, 2, 3. This is 2 is like your x, 3 is like your y, right? So substitute your y value, substitute your x value in there. So y is 3. My x is 2. So it's 2 minus 4 squared minus 1. 2 minus 4 is negative 2. Square minus 1. Negative 2 squared is 4. Minus 1. Solve for a, you're going to add 1, add 1. I get 4 equals 2. 4a. And then solve for a by dividing both sides by 4. You get a equals 1. Okay, so what we have right now is y equals a. Y equals a is 1, so you don't really have to put that one if you don't want to. Now, this is not our answer. We have to convert it to standard form. So in order to do that, we just got to FOIL this out and then bring down the negative 1. So x minus 4, when you FOIL that out, that it's going to be x squared minus 2 times ab. So if your a is x and your b is 4, that would be negative 8x, right? Yes, negative 8x plus b squared, so that would be 16 minus 1. So that's x squared minus 8x, and then 16 minus 1 is 15. There you go. There's a final answer in standard form. Okay, go ahead and pause. And that's it. Let's stop here.